Hi everyone, I hope you're having a good time at Build. This session is what can Azure do for Android and iOS. So obviously here I'm going to tell you about what Azure can do if you're building Android and iOS apps, how it can help you build better applications. If you've already watched the keynote, which if you haven't, I suggest go back and watch that. There were some really cool announcements that have to do with Android and iOS coding and Microsoft. I'm not going to dive into those, but I will be focusing on Azure instead today. First off, just a little bit about me, if you haven't caught me on Cloud Cover or another event before. My name is Chris Reisner. I am a Senior Technical Evangelist at Microsoft. I focus primarily on open source and maybe non-traditional Microsoft technology as far as how we can use that along with Azure. I do a lot of Android and iOS development. Obviously, that's why I'm here to talk to you today. If you follow me on Twitter, you might be familiar with this picture. That's my dog. And then also, I'm really into sailing. That's kind of what I do when I'm not doing stuff like this. So let's go and get started by going over kind of the agenda for this session. The first we're going to do is do a quick overview of Azure, just kind of a high-level view of what it is in case you're not familiar with it. And then we're going to focus on two different things. Making more powerful apps, so services that can help you build better applications. And then building and testing apps, so services that can help you build out your applications, and whether that's building them, testing them, running them, etc. And then we'll kind of wrap up just a quick summary, and I'll provide a few ways to contact both myself and some of the teams that work on stuff relative to what we're going to be talking about today. So first, for an overview, a really popular thing that you'll hear from, and you probably have heard in a lot of the build sessions, is that Microsoft is really becoming a mobile-first, cloud-first company, and it's really more than Microsoft, it's the world. It's people are doing more things on their phones first before they look anywhere else, and people are looking at the cloud to solve a lot of their problems. So instead of getting out their traditional computer, maybe they're using their mobile phone or their tablet. Instead of having to set up your own data center or buy your own servers, people are looking at the cloud. And we're really embracing that, and this specific session is really all about that because we're really talking about how we can use the cloud to build better mobile applications. So Microsoft Azure is Microsoft's cloud platform, and that's a kind of a nebulous term for a lot of different services and offerings that Microsoft provides for application developers. And these could be developers building out, a web application, so something like, an Instagram perhaps, something like that, just a big website, all the way down to, just small, just my own little personal website sort of stuff. And then this could be also stuff for people building mobile applications, people building, big server farms, etc. Just tons of different things. And we're going to be highlighting some of the services that you see here on this graph that have specifically to do with mobile and more so specifically to do with iOS and Android. So we won't go through all of these things right here, but there's a ton of stuff in here, whether it's virtual machines and infrastructure as a service or websites, which is platform as a service, to database storage options, to authentication. A lot of these things are stuff we're going to use from mobile, but we're going to do it in a pretty simple and easy way. So when it comes to mobile and Azure, we look at kind of three different things. We want to make sure the stuff we're building is accessible, it's open, and it's easy. When we talk about accessibility, obviously iOS and Android are hugely, insanely popular devices. So when we build out services, we want to make sure these services can work with these operating systems. When we talk about open, we mean that we want to make sure you understand how things work and what's going on. So a lot of the SDKs we're going to use or we're going to look at today are all open sourced on Git. So if you want to understand how things work under the hood, you can go look at that SDK. If you want to make a pull request, you can do that. We accept pull requests, so we're very open about how this technology works. And then easy. It's all great if you can use it on the different platforms and you can see how it works on these things, but if it isn't easy for you to use, it's going to be really hard to make sense of why you would even bother. So with the stuff we'll see today, it's really easy to get plugged into both your iOS and your Android applications. So let's go ahead and jump right into talking about making more powerful apps. So the first service we're going to talk about is Azure Mobile Services. And this is something we've been talking about for a couple years now, and it's really quite advanced and it offers a lot of capabilities. Essentially, this is a platform as a service offering from Microsoft and Azure that contains functionality to do kind of the three big things are data storage, authentication, and push notifications. When it comes to data storage, by default, kind of the out-of-the-box experience you get is it's going to store data in a SQL database. What's really nice about mobile services is that the SQL database it uses is not something that's, hidden behind the scenes. You can't access it. You can't get your data out unless you're using mobile services. It is a normal SQL or Azure SQL database. So if you decide you want to take all your data out of that and put it into a different system, you can do that. If you needed to connect to that database and do more enhanced, database administration, you can do that. What's also nice about mobile services is that you can pretty easily connect it to other data stores. So if you want something like a NoSQL system like table storage or MongoDB, you can do that. If you need to connect into a SaaS provider like Salesforce or Dynamics, you can do that. A lot of functionality you get out of that data storage. As far as user authentication goes, this is a great feature that enables you to really easily give your users the ability to log in so that you can then know who they are and make sure they're only getting the data that they're authorized to see. Now, mobile services has connectivity to do authentication with Facebook, Twitter, Microsoft accounts, Google accounts, and then also Azure Active Directory. We'll talk more about the Azure Active Directory a little bit later because it extends beyond just what mobile services can do. And then another bit here is push notifications. Push notifications are hugely important when you're building mobile applications. The vast majority of mobile applications are using these push notifications, whether it's something where you're popping up something to the user or just sending information down to the application to create a very seamless, very enticing experience. As far as push notifications go with Azure Mobile Services, there's support for APNS, which supports iOS and OS X, OS X. There's support for Android for both Google Android, so GCM or Google Cloud Messaging, Amazon Android, so Amazon Device Messaging, as well as Baidu. Windows Phone, MPNS, WNS, that stuff works. I already mentioned the Amazon Kindle push notifications. And then we're also working on some other enhanced stuff for in-app messaging as well. Now, behind the scenes, you're able to actually do your coding, so build your own logic out via .NET or Node.js, as well as some other languages. And then on the client side, there are SDKs for all the operating systems you'd expect, so for iOS, for Android, for Windows and Windows Phone. And then there's also stuff for cross-plat solutions. So if you're building a Xamarin application or a PhoneGap application, you can use those SDKs inside of those applications. So this is a very compelling or encompassing offer if you're building mobile applications, so that you don't have to worry about building out this back end, or how do you handle OAuth authentication, or how do you talk to APNS when you do push notifications. Mobile Services does this for you. And this is all stuff you could build yourself, but it's going to take time, and you're going to have to be able to test it and ensure it's going to be reliable and that it's going to work and that it will scale out. Mobile Services is here and it does all this for you already. Let's go ahead and look at a mobile service really quickly. So here we are in the Microsoft Azure portal. This is the current portal. We're going to be going between this and the preview portal throughout this session. If we wanted to create a new mobile service, we could just go into New, Create, and then we give it a name. We choose whether we're going to create a new database or use an existing one. We choose what subscription we want to put it on, and then where we want it as far as around the world goes. I've already created a mobile service, so I'm going to skip past that and go into Build Mobile Service Demo. Now the first thing you see is the Quick Start page where you can choose a platform you want to start with, and it'll give you a guide for either creating a new application or connecting an existing one and just downloading the SDK. Now I've already done this, and I've already got an iOS and Android application that we're going to walk through, and then we'll kind of look through some of the portal, and instead of going through the whole creation process, we'll just look at something that's already created. So this is going to be the simple to-do application you get out of the Create a New iOS app, just with a few modifications to it. The one thing I'll point out is that I already have a to-do item table to store my data. So if I go over to Android Studio, I've got this Build Mobile Services application here, and the first thing we'll do is we'll just run it, and then we'll walk through some of the code. So it's going to go ahead and assemble our application, and we'll choose to run it on our emulator. And then we'll go over here to our emulator, and in just a moment we should see our application running. All right. So the application is going to launch up. The first thing we're going to see is it's going to prompt us to authenticate. I've already added authentication into my application. So here we've got, I'm doing Twitter auth, so I'm just going to go ahead and type in my username. And then I will take this off screen to type in my password. And we'll go ahead and sign in. And since I'm logged in and then it shows me my ID, it's Twitter : and then a big number. What's really great is that now the client-side application has an ID for my user, and then my back end also has this ID for my user. So now I can actually start saving data, tying it to that user, doing queries off the user ID, and that's how you go ahead and you restrict access to data. So if, for example, I save a to-do item, so we'll say we're going to talk about mobile services. When I save this data on the back end, if I wanted to, I could add the ID to this data object, and then I know that this to-do item was saved by me, the user. And then whenever I get my to-do items, whenever I refresh the data, I can make sure that I'm the only one seeing this. So let's just add a couple more to-do items from Android. So to-do from Android. Let's go ahead and add that. Now if we go back to the portal, and we go into the to-do item table, we'll see that we've got some data here. Now, at no point in time do you have to specify, what data you're going to send across, being, the text field and a complete field. Mobile services use something called dynamic schematization, so that it will generate database columns and schema type for you. So let's go back to the application, and let's go ahead and look at some of the code. Most of this code is going to take place in the to-do activity. This is kind of that. If you're not familiar with Android, this is that essentially the thing that represents the page we're looking at, really. So first thing we see here is we have a mobile service client. This is part of the SDK that we're referencing. This mobile service client we're going to use kind of get our initial access into our application. We then have our mobile service table. This is what we use with the to-do item object right here. The to-do item has the different properties that we have as part of that. So an ID, a text field, and a complete field. Now if we go back in here and we look at the onCreate method, first thing we'll see is this mobile service client instantiator where we pass in the URL of our mobile service and then an application key. This application key is a unique key generated for my mobile service. And what this allows me to do is I can set security settings on the different tables and different methods, part of my mobile service, whether or not they require this application key to come across as a header. When I create my mobile service client like this, it's going to automatically send this as a header with every request. So the next thing I do after I create that is I call authenticate. In this case, if I go down to authenticate, and if you've looked at the Mobile Services SDK for Android before, you might think this looks a little bit different because we're using this stuff called futures and we're creating callbacks. Essentially, in order to better facilitate some functionality down the road, we kind of changed how it works. It still looks relatively similar, just a little bit of nomenclature changes. So inside here, we're calling login on the client object, and we're passing in the Twitter provider. If we wanted to do Google, Microsoft, etc., we could just change that right here. Then inside of that, we pass a callback, which says that when we successfully log in, go ahead and create that pop-up that says, hey, you're logged in, and then call create table. Create table is what does the actual code to say, hey, whenever I use this m-to-do table object, this is the class, this is what I'm using, it's the to-do item table behind the scenes. Then we're calling refresh items on the to-do table. And if we look at that in here, we're calling, again, we see right here we see an async task that's running and basically saying, go fetch the data where the complete flag is equal to false. So if we go back to our application for a second and we just mark this as complete, now if we refresh, that command's ran again, and this time it only pulls back the one item because we have a completed item. And then after that, we just add it to the adapter, which is basically just normal list view functionality. Then when we actually want to add an item, we create an instance of the to-do item class, we set the text and the complete flag, and then we call m-to-do table.insert and pass the item in. Really, really simple functionality for talking back to this mobile service and very Android specific. In just a second, we'll look at what it looks like in iOS, and it's going to be a little bit different because it's going to be appropriate for an Objective-C developer. One of the other things I want to show off is this build.gradle file. And if we look in here, this build.gradle file, if we look in here, we'll see that we are referencing this Azure Mobile Services SDK, this 2.02 beta. Now, this is actually in a repository, so we don't have to pull down a jar file or anything like that. As part of the Gradle build, it's automatically going to pull in the library, the code for mobile services. Now, let's go ahead and hop over and look at this on iOS. So here I have a very similar application that I'll go ahead and run. And there we have the simulator pop-up. So the first thing we'll do is we'll log in here as well. Different application running on a different device, and we need to log in again. So we'll type in our password here. and sign in. And we see that we have similar data here. I've still got some data left over from the last time I ran this. But if I say from iOS, we can add an item. And now if we go back to our Android application, we refresh it, we see that we get the data. So now it doesn't matter which device we save the data on, the other device can see that data. So looking at our Objective-C application, first thing we see is here in Objective-C, we've added a Windows Azure Mobile Services framework. This is just like how in the Android application we compiled the jar from the repository, or we pulled that in from the repository, except here we actually add a framework. Now inside here we've got this to-do service class, and this is going to have some similar code, or similar objects at least. So we have an MS client, again that's the entry point to talk to our mobile service. Then we've got a add item method, a complete item, and a sync data. So if we go to the to-do service class here, when we look at the creation, we see same build mobile service.azure-mobile.net URL, and then the exact same application key. Again, that has to do with security, we'll look at in the portal in just a second. So there's some stuff in here that we're not going to look at too deeply, but it basically, the iOS SDK is pre-built to store data locally using core data and SQLite. I'll talk more about that when it comes to offline data sync in a few minutes. But down here, we create a sync table with a to-do item name. When it comes to adding an item, we pass in an NS dictionary with the item, and we'll look at the code to do that in just a second. We pass in, or we call insert on the sync table, and pass in that item. So very similar to what we had in Android, where we call insert on the table object. When we want to complete an item, we call update on the same sync table. And when we want to sync the data down, we call pull data, and pull data is basically creating a query where all to-do items, it's creating a query where the to-do items are equal to, or the complete flag is equal to false. Now if we go ahead and look at the to-do list view controller, this is kind of the UI portion of it if you're not familiar with iOS development. If we go down here to where we first log in, here we're calling login view control provider on the client. This is a way of generating a view that wraps that web login that we did against Twitter. We pass in Twitter here, just like before. If we wanted to pass in something else like Microsoft account or Google or Facebook, we could. And then when we've authenticated successfully, we call refresh. Now, when we actually add an item, when we fetch the data, this is what's happening here. We're saying, hey, we want to fetch the to-do item data where the complete flag is equal to no. Just like we did in Java, just a little bit more specific of doing it in Objective-C. And then when we actually go to adding an item, here we just create NS dictionary, so basically a key value pair set. We pass that into the add item method in our to-do service, and again, behind the scenes, that's calling insert on our sync table. So a little bit different code, or definitely different syntax-wise, but it's doing the exact same thing as what we did in our Android application. So let's go ahead and look at the portal and look at a few different things. First thing we'll look at is the script column. Now I don't have any additional functionality in here right now, except for, once this loads, we'll see that I am logging data, and we'll look at this in just a second. And essentially what I'm doing is whenever I insert an item, I'm logging the user object. And this contains the user data, so the user's ID. And what's really great about these scripts is this is where I can put added functionality. So if I wanted to do data validation, like make sure the text of my to-do item was only a few characters long, I could put it in right here. If I wanted to check and make sure the user ID was valid, I could do that here. Though I know that since this request is made through, the user ID is valid. But I could do any sort of checks or logic here, whether it's calling a third-party service, maybe I want to ping Twitter, anything you might want to do, you could do in here. Now I mentioned mobile services use dynamic schematization. You can also, if you want to, add columns from here as well as remove columns as well. Then I've mentioned security, and essentially by default the security level on mobile services is that as long as the application key comes over as a header, the request goes through. But you can change that to 3 other settings. Everyone allows you to basically just, as long as you know the URL, you're able to make the request. Only authenticated users means that user object has to be full and valid. And mobile services is going to make sure that user object is valid again for you. And then only scripts and admins is another way of locking it down so that only other scripts can access the table, or someone that sends a master key, which is an additional key, somewhat like the application key, over to your service. Another bit of functionality that mobile services has is custom APIs, where basically when you make a request against a table, it's using a REST API that's generated for you. With custom APIs, you can create a new API, specify permissions just like we did before, and you can define whatever functionality that is not tied to an actual table. The scheduler allows you to create scheduled jobs that can either run on a schedule, whether it's every few minutes, every few hours, every day, or on demand, so just one-offs. And when you create one of these, you are able to add the same kind of script that we looked at just a second ago, where you can put in whatever functionality you want. So maybe you want to clean up old data. Maybe you want to send a regular push notification. Any of that functionality can be put in here. Push notifications is something interesting. Push notifications is actually powered by another service that's part of Azure called Notification Hubs. We're going to look at Notification Hubs in more detail in a few minutes, but suffice to say, mobile services has really easy connectivity into push notifications, where you just need to set up your credentials to do the push notifications, and then you can register from the device using the mobile services SDK. Now, identity is where you put any of the settings for the identity providers you want to use. So right now, I've got Twitter in here and I've got Google in here. And this is what allows me to use the Twitter authentication. Because if I tried to use Twitter authentication without putting these settings in, it wouldn't work. Similar, like if I tried Facebook right now, it wouldn't work. And the way you get these settings is you go to the Twitter developer portal, the Facebook developer portal, and you create an application there, and essentially you give them the URL of your mobile service, and then they give you back this information so that you can set up authentication. The last couple tabs, first we've got configured. This allows us to change what SQL database or SQL server we want to reference. The scripts behind our table access, our custom API, our scheduler, they're all available in a Git repository, so you can pull those scripts down locally, make changes, and then push them up, and that will redeploy them on your mobile service. You can turn that dynamic schematization on and off. I'll talk more about hybrid connections a little bit later. For cross-origin resource sharing, this allows you to basically use an HTML JavaScript library to access mobile services. And in that case, in order to make that cross-domain JavaScript request, you need to put the domain you're coming from into this system. There's some developer analytics systems you can use. And then there's a few different settings and monitoring things. As far as scale goes, right now this mobile service will be in the free mode. Like many of the other options in Azure, there's a free mode that lets you play around and develop essentially perpetually without having to worry about paying a price. Now, it's not true perpetually, but there's no, we're not charging for it. Those are limited though as far as what you can, how much you can use, so how many requests you can make. Once you go up to basic or standard, you're then able to scale up the number of units or how many requests you're going to make a month. And you can also do auto scale and scale it by the number of API calls, so you're not paying for more than you want to. So we'll just go back and set it to free. And now we'll look at the logs. Now, I showed you before that when I saved a to-do item, I'm actually logging the user ID, the user object. So in here, we see a log entry for the user object, and we see that my level's authenticated. I'm an authenticated user. I've got my Twitter ID here, and if I wanted to, I could call this get identities, and I can get more information from Twitter. So that's mobile services. A lot of functionality makes it able to build really powerful mobile applications without having to worry about how all of this backend stuff really works underneath the covers. So let's go back to the slides. Now, I mentioned this when we looked at the iOS SDK, but part of mobile services is a feature called offline data sync. Now, this is something that's primarily a client-side feature. And what it allows you to do is instead of just sending your data directly up to your mobile service, you can send it to a local table, which is powered by SQLite. And in the iOS instance, it's using core data on top of SQLite. But then you can sync that data against your mobile service. And what this means is that if your device goes offline, you can still make your application work. It will just write the changes locally, and then once you get back online, you can then push the changes or sync the changes with your server. Now, right now, the client SDK for .NET and iOS are public. The Android one's currently in beta, so you can use it, it can work, it just isn't production ready. Again, all of these are using SQLite behind the scenes. Now that sync is developer controlled, so you can dictate when you want to sync. So maybe you don't want to sync a lot of data if they're just on their cellular connection, but if they're on their Wi-Fi connection, you do. You can control that. Behind the scenes, on the server side, it uses something called optimistic concurrency, and essentially what this means is the first write wins. So if I have two different applications, maybe one running on my iOS device and one running on my Android device, and I am offline in both, and I make changes to the same data, and the iOS device pushes the saved data first, when my Android device connects and tries to push the data, I'll get an error back that says, hey, you don't have the latest data that you're trying to update, you need to solve this problem. And when you get that sort of conflict, you can handle that on the server side or on the client. So if you just wanted to overwrite the data, you could just do that on the server side. But if you want to present something to the user and say, hey, this is the actual data that's current, are you sure you want to save your data? You can do that on the client side. Now, Azure Mobile Services has been around for a couple years, and its focus was really on building mobile applications. But there's a few other services that are part of Azure that are really useful in conjunction with mobile services. So there's Azure websites, which allow you to deploy web applications, whether they're .NET, Java, PHP, Node.js, or other languages. And this has a lot of really cool functionality, like you can do site slots. So you can say, I want a test environment and a production environment. You can do automated backup and restoring. You can do a lot of other really cool functionality. But even though mobile services is kind of built off of Azure websites, you couldn't use that same functionality from Azure websites. And you couldn't host, a web application inside your mobile service that was, for your mobile application. You'd have to host that separately inside of an Azure website. Now, additionally, there's services, some called BizTalk services, which allow you some increased functionality for mobile applications as well, such as connecting from a mobile application back to an on-premise database or web service. Now, what we just recently announced is something called Azure App Service, and this essentially combines this functionality all together in addition to some other functionality. So with Azure App Service, you're now able to build web apps and mobile apps and logic apps and API apps. And really right now, what we really focus on is these web apps and mobile apps, because the mobile apps is essentially the future of mobile services. So all the functionality in mobile services is right there in mobile apps. But additionally, you're able to deploy as kind of a bigger piece other pieces of the application. So the same place you deploy your mobile app to, you can deploy your web app to, and it's basically one application. So no more worrying about what's going on over here in your Azure website, what's going on over there in your mobile service. It's all one app service. Some of the new capabilities for mobile apps that we had with Azure websites but are now capable of being used from mobile applications include long-running tasks for web jobs, continuous integration with GitHub, Bitbucket, and VSO, auto load balancing, auto scaling, as well as geographical disaster recovery, virtual networking and hybrid connections, and then that site slots for stage deployments that I mentioned. And this is currently in preview, so if you're building a production application, you should still use mobile services, but down the road when this goes to general availability, this will kind of be the future of mobile connectivity when it comes to Azure. So let's take a quick look at just how we would set up an app service and what it looks like. In order to do this, we're going to actually go to the preview portal. And inside here, we can go in and I can create a new mobile application. And inside here, it's going to ask me for a bit of different information, like where I want it to be, what I want it to be called, stuff like that. Now I'm going to skip past this. I'm just going to go into a mobile application I've already created. And inside here, we can see I can add a client. Again, this is just in preview, so not all of the clients are here. So where we saw all of the Android, iOS, Xamarin, PhoneGap, Windows Phone before, we only see a few of them here in preview. We can go into the different authentication options as far as users that can access this and what they can do with it. We can go into the settings and see the different user authentication and other options, things like that. We can get to the keys, we can see our push notification services. Essentially, like I said before, all the functionality that was there before in our mobile service is going to be here. Now, one of the other things I'll show you and highlight is that when you grab an application, so for example the iOS app, you can you download not just the iOS application, but also the server side. So the deployment model here is a little bit different, whereas with this mobile service, we're doing everything in the portal. Here, for the visuals, for the .NET piece, you would grab a Visual Studio solution and then deploy that for your mobile app. Now, again, this is in preview, so we don't have the Node version yet, but it's going to be coming down the road. So let's go ahead and head back to our slides. So the next thing we'll talk about is notification hubs. Notification hubs facilitate managed push notifications. And this works, like I said before, with Android, iOS, Windows, and Windows Phone. And there's several different varieties of Android push notifications it works with. Now, I'm going to show you this for both iOS and Android, but some of the features that notification hubs light up for you is targeted push notifications. So if you wanted to push to Chris's phone, for example, you'd be able to do that. Or if you want to push to everybody that's at Build, you could do that. And it facilitates doing cross-platform, so push to both Android and iOS and Windows Phone really easily using templates. And one of the great things about notification hubs is it's highly scalable. So if you need to deliver millions of push notifications, you're going to be able to do so. So let's go ahead and look at notification hubs. First thing we'll do is we'll go back to the portal, and now I'm going to go into Service Bus, which is what notification hubs are part of. And I'm going to go into this notification hub that I've already created called Build Mobile Apps Hub. Now inside here, similar to what I told you before, how we configure our push notifications for mobile services. Again, it's using notification hubs behind the scenes. But if I go into configure for notification hubs, this is where I can set my Windows notification settings, my Apple APNS settings, my Google Cloud message settings. Now I've already uploaded a certificate and set up GCM. If I wanted to, if I was just setting up GCM for the first time, I would go into an application in the Google Developer Console. I'd go to APIs. I'd turn on Google Cloud Messaging, or Cloud Messaging for Android right there. And then you just grab a server key, which is how my notification hub can authenticate talking to Google's Developer Console. So I've already got this set up. From a client side, the two pieces of information I need then are the name of my hub and then the list and shared access signature so I can actually register with the hub. So then let's go ahead and look at this on an Android application. So let's first run our application. And we'll run this on the emulator. And this is going to be a really simple application. Essentially what it's going to allow us to do is register with our notification hub and then get push notifications. So we'll let that run in the background. Okay, so here we are. So we see that we haven't registered yet. I've got a button to register with GCM, and then I've got a few different buttons to register with my notification hub. First thing I'll do is hit register with GCM. This goes through my application. It basically uses the Google Cloud Messaging, which is part of Google's Android APIs. It goes up to GCM. It says I want to register and passes in a sender ID, which is another ID I get from the Google Developer Console. So when I hit that, I get back this really long string, which identifies my application and my device to GCM. Now after that, what I can do is I'm going to use this notification hub object I create using the hub name and that listen string I mentioned before, and I'm going to call this register method. And I just passed in the registration ID. So I'll register with no tags. Now what I'm going to do next is I'm going to go into a different mobile service which I've set up to help me do some push notifications. So I've got some custom APIs in here that I can just access via the web, and the first one we're going to look at is just a method to push to GCM and APNS. So if we go and look at this script right here, we'll see that I've got the hub name again, and I've got a different connection string. This one has full shared access. This is a full access signature, so that means I can actually not just register, but I can actually trigger push notifications. So then down here, I'm using the notification hub service. I'm calling apns.send, and I'm passing in a payload for that. And then I'm also doing gcm.send and passing in a payload for that. Now let's go ahead and refresh this page right here, and if we return to our application, we see hello from Azure, and if I look up here, I can see that I've got a push notification showing up. Now, the next thing I want to do is I want to actually run this in iOS. So I've got a similar application over here in iOS, and much like before, I am creating a notification hub with the name and the string. I'm registering with APNS, that's going on behind the scenes. I'm getting back a string, and then I'm registering with a device token. I'm just passing that token in. So let's go ahead and run this application. And I'm going to go ahead and screen share so we can actually see this running. And there we go. So now I'll return to the application. We've already got our token back. We'll register with no tags. Now what I want to do is I'm going to go over here. I'm going to refresh. I'm actually going to get my emulators ready so we can watch them. I'm going to refresh. And we can see, look, the push notification went to both places. We see it from iOS and we see it through on Android. So let's go ahead and go back to the code, because now we're going to look at these register with tags method. And what this allows us to do is when we do the registration, we can say, I want you to tie specific information to my registration. So in this case here, I've got Bill, I've got Android user, and I've got all users. And I'm using just an overload of the register method where I pass in the registration ID and then a list of strings. If we go over to iOS, we'll see that we've got a very similar thing. We have an array of strings. We pass that into register with native with device token. We do the token data, and then our tag set. So now if I go back to my two applications, we register with tags from our iOS app, and we'll go to our Android application, and we'll register with tags. Now, we'll go back up to the portal, and we've got a different method here called pushTestTag. And this is going to be very similar, except now the first parameter to send is build in this case and Android user in this case. So I'm sending, when I say apns.send and I pass in build, it's going to look for any tag that's registered with that build, any registration that's got that build tag, and it's going to try to push to that. And then when I do GCM, it's going to say, hey, anybody that's registered with Android user, push to them. So let's go ahead and here go to our website and just do push test tag. And if we look here, we can see we've got hello build, and then we got that push notification on Android as well. And we can look at that if we just go right here. So hello Android users. So now I can target the push notifications for one specific device or another specific device. Now, so far I've had to do both push notifications for GCM and APNS separately. That's really not ideal. I don't want to have separate blocks of code anywhere I want to do a push notification to handle each provider. What I can do instead is when I register with my notification hub, I can pass in a template. And this template can dictate what format I should receive a push notification in. So if we look at this template for Android, we see I've got this data message and then this $ message right here. And what happens is whenever I send a message parameter or a message field as a push notification to a templated push, notification hubs will deal with A, pulling out the right recipients based off the tags, and then getting the data in the right format to push to, for example, in this case, GCM. If we look over at the APNS one, or the iOS one, we'll see it's a little bit different, but it's got that APS alert and that same $ message. So this is the right format for APNS and not GCM, but that's, of course, because when I get a push to this iOS application, it should be using APNS. So I'll hit register with templates on both my devices here. And now we'll go back to the portal, and I'll go to this push test template page. And inside here, I'm creating a payload where I've got this message parameter, and I say template push to everyone. And then I call notification hub service.send. So don't send to either GCM or APNS, just send to anyone that applies to. I'm not sending a tag here, but I could if I wanted to, and then just pass the payload in. So now we'll say push test template. And if we go back to our iOS device, we see we got that push. And if we go to our Android device, it was too fast, but we see it right here. Let's see if we can refresh it really quickly and then see template push to everyone, and we got it again on iOS as well. So a really powerful way to get push notifications regardless of what type of application or what operating system you're building. And then additionally, regardless of whether you're using Azure for data storage or user authentication or anything else, you can just use this service just to do push notifications like I'm doing here. And in addition to having the client-side SDKs that work with Android and iOS and Windows Phone, from the back end, there's a lot of ways of talking to your notification hub to actually trigger push notifications. You can use a .NET SDK to talk to your notification hub. You can use a Node SDK, which is essentially what I'm doing right here, is I'm using this Node JavaScript SDK. There's also a Java SDK. And then everything is actually exposed via a REST API. So if you're building an application backend that you want to talk to notification hubs with, but we don't have an SDK for it, you can just use the REST API, and it's very easy. So let's head back to the slides. So a few services we'll talk about that we won't show in real detail, we'll get into now. The first one is Azure Storage. Now, so far, when I showed you mobile services, we were using SQL database behind the scenes to store our data. And I mentioned that this is just, built into mobile services. You can change that if you want. Azure Storage facilitates a few different kinds of storage, including NoSQL via table storage, files and large data via blobs, and then messages and subscriptions via queues. Now, there's an Android SDK available for this, so if you need to talk directly to these storage systems from an Android application, you can do so. There's an iOS one in progress, and if you're interested in that, you should get in touch with us. I mentioned authentication earlier, and I talked about how you could use Azure Active Directory for mobile services. Now, Azure Active Directory is just a system that stands on its own, though, for authentication. And what's great about Azure Active Directory is that there is an Azure Active Directory authentication library for iOS, for Android, for all these other operating systems that you can use to authenticate users, again, regardless of whether you're using another system, within Azure. And what's great about Azure Active Directory is you can sync this with your on-premise Active Directory. So if you want your employees to log in with their corporate credentials before they can access some sort of service or some sort of application, you can use the Azure Active Directory library to make sure that that happens. This uses industry standard and secure OAuth 2. It enables you to access APIs like Office and SharePoint without having to prompt the user every time. And like I mentioned before, it syncs with on-premise. You can make it sync with on-premise AD. Office 365 is Office in the cloud. And there's a library that allows you to access your SharePoint online files and lists, your Outlook, mail, calendars, and contacts, as well as your Azure Active Directory graph, and it works with the ADAL. So essentially you can use the ADAL library to authenticate your users and then start making calls using the Office 365 SDKs. Media Services is a really cool service that lets you do video on demand. So from an administration perspective, you can ingest new media, you can encode it, you can package it, and you can also deliver it down to applications. Now it's really quite easy to get this to watch this on both mobile or web, and there's different authentication options whether you need to do full-on DRM, so think that you want to be able to distribute media and ensure that nobody can duplicate it, up to just secure media, so you want to make sure it gets there securely, but once it's there you're less concerned. Another service we'll talk about really quickly is BizTalk Services Hybrid Connections. Now this is going to be part of that new Azure App Service, but for right now you can still use it for mobile services as well as hybrid connections. And what this allows you to do is point an endpoint within Azure and an endpoint within your enterprise using a hybrid connection manager. So whereas by default mobile services is using a SQL database inside of Azure, you could use a hybrid connection to point that at a SQL database running in your own data center. And then mobile services will basically automatically funnel all traffic through this hybrid connection so that all the data is only being stored in your database in your data center as opposed to Azure. You can use the same thing to talk to internal services, whether they're web services or any other endpoint you might want to. So the next section we'll talk about is just building and testing apps. So if you're building an application, what else can you use from Azure to help you do that? The first thing we'll talk about is Android plugins, and we have these for Android Studio and IntelliJ. These allow you a really easy way to connect to Azure mobile services, and whether that's to connect to an existing or to create a new one, notification hubs, as well as Azure Service and Office 365 activities, including setting permissions. Let's take a really quick look at the Android Studio plugin. So I'll just go back to Android Studio, and I'm just going to go to my application, I'll go to New, and then I'll go down to Microsoft, and I can choose Azure Service Directory, and it'll basically allow me, create an activity which wraps the functionality of talking to my mobile service or notifications or both. If I go back and I say New again, I can go to Microsoft and Office 365 activity, and it lets me create another activity that again can dictate whether I want to talk to Outlook services, the file services, or SharePoint lists. Another little bit of functionality inside the plugin is you're actually able to go in and see your mobile services, your virtual machines, and your storage accounts, connect to those as well as spin up new ones. And you'll see added functionality added as time goes on. So Visual Studio Online is a really cool tool. It's not essentially Visual Studio, the IDE, online, but what it is it's project management, but it's really enhanced. At the base, what you get out of it is you can do version control, and you can set this up with Git or TFS, and it's free for up to 5 people. You can also do more actual project management, so you can create bugs, you can create tasks, you can track work items, all that stuff. And then some really cool functionality is stuff that we previewed last November, and it allows you to build applications in a continuous integration for Android and iOS. And this includes running your test as well as publishing compiled apps. Let's take a quick look at some of the stuff that we'll have coming there. So if I go back to the browser, so this is Visual Studio Online, and if I wanted to create a new project, I could do so really easily. I just give it my name, say build project, and then I can choose what process template if you want to do that, and then we can choose between Team Foundation version control or Git. Now there's nothing weird about this. This is traditional Git, so once you create this Git repository, you can use the Git command line tools to start pushing and pulling your code into Visual Studio Online. Now I've already created a repository that contains all the code samples I showed you today. Now we could go in here and we could look at the code if we wanted to, but let's go into this build preview. And again, this is functionality that we'll have coming down the road, but it is in preview right now. So what I could do right here is I can create a new build definition, and I'll just say it's an empty definition. Notice that we have a few templates already for Visual Studio, Xamarin, Android, and Xcode. And then once I've created a definition, I can go to add build steps like Android build, so build my Android application, or sign my APK. I could go down here and do an Xcode build and an Xcode package iOS, so to actually build the IPA. What's really cool about this is, I've got several different projects in here, so I could have several build steps or several build definitions, and I could just point to, where is my build, my Gradle wrapper, which project directory am I using, should I run the Android emulator, do I run or run tests, and then here I can actually say, I want you to sign this and create an APK. So this creates some really cool functionality where you can basically automate building your application, running tests, and getting an APK. So think of, you're testing your application out in your enterprise, your company, and every time you make a code change, you want to make a new APK available for your testers. This can do that. You can build this application every time you make a code change. If it passed tests, you can create a new APK using the signing step, and then you can write a script at the end that will take that APK and maybe email it to your users or deliver it to wherever it needs to be so that they can install it. And the same goes for Xcode. Xcode is really interesting because we can't exactly right now build that iOS application online, but you can pair Visual Studio Online with a build machine, so an OS 10 machine, for example, and build that Xcode application that way. And then you have that same capability to package that up and then deliver it somewhere if you want to. Really very powerful stuff for doing continuous integration and building out your applications. App Insights provide easy application monitoring. And this is essentially availability and performance monitoring of your application. You can track usage and metrics. You can review app crashes information there. And you can also get backend telemetry. So let's say you're doing that Azure App Service and you've got an application and you also have a mobile or a website for that application. Well, you can use this Azure or App Insights to get information on the usage of your mobile app as well as your website. Let's take a quick look at what this looks like. Now, I've already added some code into this Android application to do App Insights. First thing you see is I just added this compile directive into my Gradle file. So it's going to go out and pull down the App Insights library, which is available on GitHub like all the other SDKs we've seen today. And then in my to-do activity, or let's go back to the manifest first. In my manifest here, I'm specifying an instrumentation key, which I get out of the portal, and we'll look at that in a second. And then in my to-do activity in onCreate, down at the bottom here, I'm creating an instance of my telemetry client. I'm calling track event, and I'm saying app start. If I say track event, if I look for track event, I'm also doing it when I have an item added. So since I did this stuff earlier in my application, if we go to the portal, we should see some events that have been logged. So we'll go back here to the portal. I'm going to go and return to home, and I'll go to build mobile app insights. Now, if we look in here, we should see that we already have a few events logged. So we've got events logged. My app hasn't crashed, so I don't have any crash data here. But I can see that I've started the app 5 times. I added one item, and I updated one item. I can see where the requests were made from. I can go to the Metrics Explorer and look at additional information after I configure it. So what sort of metrics do I want to get? A lot of options there. If I go down here, we can see, what version of the Android SDK was being used. In this case, it was built for x86. It was 5.1. That's my screen resolution. Tons of really great information here. And as far as getting set up goes, if we go to, the Quick Start, it explains what you need to do to get up started and running. And then if I go to settings, this is where I can grab that instrumentation key that I put inside my application. So like I said, really easy to get this up and running, and you start getting really great information about the usage of your application. And it works on Android, it works on iOS, as well as all sorts of other devices. Let's go ahead and head back to our slides. Now, Visual Studio Online is that online component we just looked at where we hit source control and we can build out a project and do project management. Visual Studio itself has some functionality if you are building Android and iOS applications. So there's easy connectivity into Cordova, Xamarin, doing C++ builds and deployment and debugging. And there's also an Android emulator that runs as part of Visual Studio to help you better test out and run your applications. So to summarize what we looked at today, Azure can power your backend no matter what you're building as far as a mobile application goes. So there's Azure Mobile Services, which is production approved right now. There's Azure App Service and Mobile Apps, which is in preview right now, and it's kind of the future of where we're going. There's Notification Hubs, which handle push notifications, and that works with mobile apps and mobile services, but can also work as a standalone if you just need to do push notifications. There's Azure Storage and Azure Active Directory, as well as hybrid services for making more powerful and interesting applications. And then as far as helping you build better applications, there's Visual Studio Online, there's those pieces in Visual Studio, there's App Insights, and then those IDE plugins we looked at. Thank you for tuning in and watching this. I hope you've had a great time at Build. If you want to reach out to me, you can always do so on Twitter at Chris Reisner. You can reach out to me via my website, chrisreisner.com. And then if you have feedback on mobile apps or services, you can email mobileservices@microsoft.com. And then we always welcome feedback and user requests at feedback.azure.com. Thanks, everyone, and have a great day.